Hello, this is Scholar Strategy Students Math. Today in geometry, we're going to be looking at inductive reasoning. So let's look at some vocabulary. A conjecture is an unproven statement based on observations. A counterexample is a statement or diagram that proves a conjecture false. And then to make a general inductive reasoning is to make a general conjecture after observing specific patterns. And deductive reasoning is to make a logical argument using facts, definitions, properties, rules, or laws. So we're going to look at our inductive reasoning here. So draw the figure in the next pattern. So we start out with two boxes, and then the bottom one is shaded. And then in figure 2, we have 4 boxes now. So we have 2 more boxes, and the bottom left is shaded. And then figure 3, we add another 2 boxes, and the bottom left is still shaded. So based on our observations, figure 4, we're going to add 2 more boxes. One, 2, 3, and then split in half, and then we're going to shade the bottom one. So that's how we use our inductive reasoning. Example 2, describe the pattern of numbers. What are the next 3 terms in the sequence? So we have -1, -4, -16, -64. What's going on here is we're multiplying by 4. So the next number would be -64 times 4, which is 256. Times that by 4, 1024. Times that by 4, 4096. And they were all negative. Alright. Given 5 non-collinear points, make a conjecture about the number of ways you can connect any 2 of the points with a segment. So, if we have 1 point, we can make 0 connections. If we have 2 people, or 2 points, we can make 1 connection. 3 people, there are 3 ways, 3 connections. If I have 4 dots, 4 points, 6. So what's going on here? So we added 1, then we add 2, then we add 3. So the next one would be add 4, which will make this 10. The graph shows an average salary of the NFL players since 1999. Make a conjecture from the graph. So remember, a conjecture is unproven, but unproven statement. But you can obviously guess that an NFL player will earn more in 2004 than in 2003. Because the 5th year here is 2004. So obviously what we're saying is he's going to make more money each year. Based on the average player's salary, their salary is going to go up the next year. He's going to make more than what he did in 2003. Oh, is that it? Well, that was pretty quick. So the big idea about inductive reasoning... You know what? I'm going to add some things. I'm going to insert a page. Oh, I wanted this. Here, let me delete this. Insert page. Insert. Alright, I'm going to draw a picture here really quick. Let me pause the video really quick. So there's some things that you can assume from a diagram. So let's say I have this diagram here. It's a little sloppy, but basically they're all on the plane P here. So you can assume. So let's say you can assume. So all these points that are shown here are coplanar. So all points shown are coplanar. So you can assume whether or not a point is on the same plane as another point. Usually they are when we give you a problem. You can assume that two angles are supplementary if they add up to a straight line. So for example, angle AHB and angle BHJ. So let me color those. AHB. So we're talking about this one. And BHJ. So we're talking about this one. We can assume that they are a linear pair because they are next to each other and they add up to a straight line. So we can assume vertical angles. So opposite. So we can assume vertical angles. So if we have an intersection, this angle here is congruent to that angle here. And then the opposite diagonals are congruent to each other. We can assume that points are collinear. So DJHA, they're all on the same line. DJHA are collinear. And we can assume that lines intersect at certain points. So the line BF and the line AD intersect at H. Things you can assume, like for example, because they need to have a line connecting them, G, F, and E, they're not collinear because they're not on the same line. We don't know that B, F, and CE intersect. It looks like it does, but we can't assume that until they cross each other. Angles being congruent to each other, unless they're vertical angles. Angles can look like they're congruent, but they need to have either a symbol or they need to be vertical angles. Things being perpendicular, can't assume perpendicular unless there's a right angle. And finally, you can't assume things are 90 degrees unless they give you a right angle. So I added a little bit more than I should, but that's that for 2.1.